if we do, to test this log here, if I do 10 to the power of this number, because again, the calculator just told me that, hey, if you put 10 to the power of this, you should get 5469. So if we do that, and I just put the whole decimal in there as the answer, here we go. I get back exactly the number that I put in. Okay? So again, it's helpful to think about a logarithm as an exponent this way. So if you have log base 3 of 27, what's this? Well, you're looking for some value, and that actually is 3 to some value equals 27. Again, so going back and forth between these forms are going to be helpful. And y is then what? Okay, you see that? So y is 3. Okay. Questions so far? I know this is quite abstract, kind of off the wall here. One thing I might do though, sorry, question? No? One thing I might do is go back to the calculator real quick. And if we go to the y equals function, go to the y equals, clear off everything that's there, and make sure your plots are not highlighted. And let's do y equals 10 to the power of x. Or you could, I guess, just do this second function, 10 to the power of x. Okay. And then let's do log of x. And we said that those should be inverse functions. So if we graph those, I'm going to hit zoom 6 to get a standard window because I don't know what my window is like. I get this. Okay, so I don't know if you can see that or not, but we have an exponential function here really close to the x-axis, and then it comes up here and it takes a sharp turn upward, right? That's 10 to the power of x. This right here is y equals log of x, logarithm base 10 of x. And do you guys remember about inverse functions from previous chapters? How they on the graph, they're reflections about the line y equals x. So again, if this was a square screen, this would look exactly symmetrical around this line that would go here. All right. So they are inverses of each other, and that's what their graphs look like. And we're going to explore this graph a little bit more as we move through. Okay, so if we look at a couple examples here, this will help us understand what we're doing here as well. If we look at A, we're trying to find the value of x. Just remember, again, super important, the base is the base in an exponential equation. This over here is the exponent, because remember the logarithm is an exponent, so that's an exponent. So 5 to the negative 3 equals this value. So that's how you set up your exponential equation. And again, this is going to help you solve, to figure out these logs. And so 5 to the negative 3, of course, is 1 over 5 cubed. And 5 cubed is 5 times 5 times 5 is 1 over 125. Okay, that makes sense? All right, most of your calculators will not be able to plug in this 5 as a base. Some of your calculators will, but most won't. The only logarithm on most of your calculators is log base 10. So I'll show you how to do this on your calculator, but for right now, it's not going to be, you're going to be able to do this without a calculator. Okay, so let's move on to the next one here. Again, setting up this equation becomes pretty easy. It is x as a base to the power of 2 equals 36. And so if you set that up, you know what? This is pretty easy, isn't it? If you want to show your work, or if you're unsure about that, you should know that in your head. But this 36 can actually be written like this, right? And so remember that property of equality with exponents? Exponents are equal, bases are equal. So if we have the exponents equal, we know that the bases must be equal as well. So x equals 6 is your answer for B. Good? Okay, and this one last example it'll do here, maybe a bit trickier, but again, start with your base, 64 to the power of, we have a fraction, 2/3 equals x. Okay, what's the cube root of 64? And if you are wondering what to do, remember that the denominator of a fractional exponent is actually the index of the root. Okay, and that number on top is just like a regular exponent. So this might be, again, don't even need your calculator. You might, but what's the cube root of 64? Something times itself, sorry? Not 2, I thought I heard 2, but it's 4, yeah. So 4 times 4 is 16, times 4 is 64. So this is 4, and then you have that squared, and so 16 is your answer. And of course, you can check that out on your calculator by doing, okay, by doing 64 to the power of 2/3 equals 16. Okay? Good? Questions? Okay, so here's your quick review of the lesson. We talked about the logarithm as an exponent. Okay? There is an equivalent form, exponential form, and logarithmic form. You can go back and forth here. So the y value, okay, in the exponent position is like the y value in the log equation, like that. So we talked about how to go back and forth from there. Here's the picture of the graph that we talked about. Okay, the exponential graph here in blue, and the log graph as a reflection about the y equals x axis. For a logarithmic function, which we didn't talk a whole lot about the characteristics, but the domain is x greater than 0. Okay, it does not go into the negatives. And there's an intercept at 1, an x-intercept of 1, just like there's a y-intercept of 1 from the exponential, so that's a x-intercept of 1. The range is all values of y. And there's a vertical asymptote here at x equals 0, just like in the opposite exponential function, there's a horizontal asymptote there, so that just flips as well. And the common log is base 10. So there's your summary for the lesson.